always be in perfect order, but I try to like set it up so it's in order from like 2:1 through 2:4. So the first couple questions are from like the beginning of the chapter and then kind of works its way through. I threw one on here because we're going to continue to see domain and range. So number 1 is a domain and range question. The one thing that we'll say here is both of these, they don't extend forever, right? They stop at those specific points. It's not going to continue on. And so we're going to, as we go domain, we're going to go left to right. And as we go range, we're going to go top to bottom. What values are included within that? Okay, so in this case, because all of our points are brackets, or all of our points are closed circles, then we would use brackets to represent that. Okay, so just identify domain and range. Number 2, it's kind of hidden down here. I don't like how they wrote this problem out on here, but you're evaluating f of 6. We did a bunch of problems like that from that first section where when we talked about piecewise functions, evaluating it. Now remember, this tells me which function I'm going to use. If x is less than 1, we go here. If x is between 6 and 8, we go here. If x is bigger than 8, we would use the last one. We're not going to use all 3. So you're going to figure out which one to use, plug it into just that one function. Okay, I want you to try number 3 on your own. What I will tell you here, one piece of information that I think might make this easier is you're graphing 2 functions here. You're graphing y equals 4, because remember f of x really means y, and you're graphing, I would put it in slope-intercept form, because that's the form we're most familiar with, right? And they don't necessarily put it in that form. So I think that would be helpful, because we did a lot of that in chapter 1. But we're not graphing the entire line. We're only graphing this one from 1 and to the right. Okay, so just to kind of help you get started on this, if I graphed y equals 4, what kind of line would that be? Yep, it's going to be horizontal, okay? But I'm not graphing the entire line. I'm only graphing it from 1 to the right, okay? From 1 to forever. This one here, we're only going to graph it to the left of 1. So it's going to go all the way up to 1. But because it's not including 1, we want an open circle where 1 is at. Okay, so I'll give you those kind of helpful hints. I think that'll make it a little bit easier to graph. But there's only one of those, but you really need some practice doing it. Because I know that's one of those concepts that we haven't seen in previous classes before. We don't really do piecewise functions in Algebra 2. Okay, on number 4, finding a 0. There's 2 ways to do this. If you want to do it by hand, then you just set it equal to 0 and solve for x. Pretty simple. 2-step equation. You could also graph it, and it would be the x-intercept. Okay, either one of those are ways to do it, and that kind of leads into our next question as well on the next page, because it asks you to find both. What is the 0? What is the x-intercept? Okay. But it gives you a graph instead of the equation. So you can find it a couple of different ways. Okay, on number 6, the way I would write this one out is increasing, decreasing, and constant. Okay, you got your 3 different types of functions and what's happening there. One thing I will remind you of here, we are only concerned with the x values, and we only use parentheses. You don't have to worry about brackets on this one, because we're not doing domain and range. We're just identifying where is it going, getting bigger, where is it getting smaller, where is it staying the same. So you don't necessarily have to do this part, but this is one thing that we talked about. That first line up there is constant because it stays flat. So anywhere it stays flat, it's a constant function. This one here is an increasing part. This would be a decreasing part. And this would be an increasing part. But you want to tell me where is it increasing, decreasing, and constant. So increasing, you'll have two different intervals where it's increasing. So you'll have two different answers here. Decreasing, you're going to have another set, and then constant, you'll have another set. But when you write your answer, remember, only use x values. You won't use the y values. That's one thing that a lot of people miss on this one, because it's really easy to do. Like, for instance, here, a lot of people want to use 2 for that, right? Because that's where it hits the y-axis at. But that's not the x-axis. That's not the x value here. The x value here would be 0. So, like, for instance, here, this one increases starting at -2 up to 0. So as it moves left to right, it increases from -2 to 0. Okay? So kind of keep that in mind. I'll let you kind of do that one. If you need some help, let me know. Number 7, you've got several different things here they want you to do. Maximum, minimum, and then once again, increasing and decreasing. Okay, we're going to write all this out, but I'm going to label it here first of all, and I think this kind of helps as we put all this information on our answer over here. So first of all, maximum. So this is the point where it reaches its maximum. But when I say what is the maximum value is the point where it reaches its highest value. And so your maximum value is always the y value. So it reaches its maximum at 18. And that happens at x equals -2. So it's really just another way of writing this ordered pair out. 18 is the highest it will ever reach, and it reaches it when x is -2. Same thing for the minimum, okay? It reaches its low point at -14, and that happens at x equals 2. Okay, and then just to kind of show you how to write out your increasing and decreasing functions, remember you're only using x values here. So this one over here, there's no point, which means it's going to continue on. So it's going to go from -infinity all the way over to -2. So it's increasing from -infinity to -2. It's decreasing in this middle part. So it starts to decrease at -2, and it continues to drop until it gets to +2. Only using x values. And then it's going to increase again from 2 to forever. Okay, so that's what your increasing and decreasing intervals look like. And same instructions as the previous problem on 6. No brackets. Don't worry about brackets. Because like at this point here, it's neither increasing or decreasing. This is where it hits its point and it's going to go right back up. So we don't include 2. That's just where it changes its direction at. Okay, questions on that one? Okay, what I'll tell you on this one is kind of like the one we did just a second ago, but we're only looking for the maximum or minimum. You don't have to do increasing and decreasing here. So graph it. And on the graph here, you don't have to be real particular about your graph here. All that I really want to know on the graph is where does it reach its minimum or its maximum, okay? Does it have a minimum or a maximum? Like for instance, what does the graph look like when I have absolute value? What kind of shape does it make? A V, yep. So my graph is either going to look like this or it's going to look like this, right? It's either a V that opens up or a V that opens down. This one will have a minimum. This one will have a maximum. So this one has one or the other. The last one had both. Okay, it's not going to have both in this case because it's a V. Because this one extends up forever, so it doesn't have a maximum. This one extends down forever, so it doesn't have a minimum. Okay, so just find out where that minimum or maximum is. If you don't remember where your absolute value button's at in your calculator, let me know and I can show you again. I know we've talked about it a couple of times, but it's kind of hidden, especially in the TI calculators. All right, a lot of people in my class earlier today asked about this one, so I'm going to talk about this one. Because we talked about this a little bit with division. We didn't do a ton of division operations. This is on Monday. We talked about add, subtract, multiply, divide, and doing all the different operations with functions. Okay. If I was going to do f over g, then I'm going to put f on top. I'm going to put g on bottom. And what we want to know is, can I leave my answer like this? And in some cases, we might be able to leave it like this. But what we have to know is, can I simplify it anymore before I leave it like this? So my answer could be this, but we got to see if there's anything else I can do to simplify it. And so to simplify this, we would factor the top and bottom. Okay, and as we talked about earlier in the chapter, there's going to be some algebra skills that come into play that we haven't done a whole lot of review of those. So like foiling and factoring and some of those kind of things. We won't have a section that just deals with reviewing, foiling, and factoring and that kind of thing. Just for the sake of, we don't have a lot of time to go back and review a lot of those skills. So on this one here, the factoring that I would do, first kind of factoring I always look at is GCF. Is there something they have in common? In this case, they both have an X, so I can take that X out. On the bottom, what can I do to factor the bottom? What kind of factoring would we do there? What do you think, Cole? Okay, is there a greatest common factor of all three? Yep. Okay, and some of you I know haven't had me before. I call it product and sum. Other teachers may not use those words, but we got to find something that has a product of negative 36, multiplies to get negative 36, and has a sum of negative 5. So I call it the product and the sum. Other teachers may not use those exact words, but it's the same idea. Okay, so we're looking for two numbers that multiply to get negative 36 and add to get negative 5. Negative 9 times 4, negative 36. Negative 9 plus 4 would be negative 5. Okay. You guys kind of remember that? Now the question here is there anything that I can do? Is there anything on top and bottom that are the exact same thing? No. Like if this is 4x minus 9, and let's say I put a 4 right here, then I would be able to knock those guys out, okay? And then I can simplify it. But here there's no common factors. And so because there's no common factors, then we could just leave it like that. But we got to see if we can simplify it before we leave it like that. So it ends up not being a whole lot of work, right? But that's where all of those other choices would come into play. Your B, C, your A, C, and D choices, if I could simplify it, that's where they would work. What you can't do, some people want to do this, they want, oh, we got an x squared, I'm just going to knock the x squared out. Don't do that. That is like bad sin in algebra. Just because you see an x squared on top and bottom, you can't just slice those off. Okay, on all of these operation ones, things that I'll talk about, if you have a number here, we want to plug the number in. And you have two options. I can combine these two functions together first and then put in one, or I could put one into this, and then add them together, okay? We talked about the two different possibilities that you could do there. One thing that we also talked about earlier in the week when we were on this was really be careful of what comes first. Is it F minus G or is it G minus F? Because there's a difference. When we do, especially subtraction and division, then 2 minus 3 and 3 minus 2 are not the same thing, right? So order matters. We can't just put whatever we want in front. So sometimes you might see F minus G, sometimes you might see G minus F. And we've seen both of those. We've done examples of both of those. Just really be careful of the order. Now, if I was going to do one like number 12, I would be really careful about writing this out. I would go, I mean, it takes a little bit of time here, but I think it's well worth the time, because in most cases, I feel like if you don't write it out like this, you're probably going to miss it. Okay, we're taking F minus G. I'm putting both of them in parentheses, and the reason why I think it's really, really helpful to write it out is because we are going to have to take that minus sign and distribute it. If I don't put that in parentheses, I'm going to forget to distribute. Most common mistake that's made. Been teaching college algebra a long time, and I see it all the time. Okay, so just trying to give you some helpful hints there. And so on the blank, just put, for ones like this, your answer is just going to be a number, right? So just put what your answer would be. But on number 12, your answer is going to be an expression. Okay, we see some more of those. All right, number 15. These are what we did yesterday. These are the composition problems. Really, once again, pay attention. Is it G follows F or is it F follows G? Order matters when we do this. This one is G follows F. This one is F follows G. So they're a little bit different kind of problem. We work it basically the same way. And what I told you is you could do two things here. You could do the composition first and then plug the number in. Or what we said is if I just have a number here, I'm just working backwards. I'm taking negative 15, plugging it in to the F function. Whatever answer I get here, I'm going to plug it into the G function. So we're working backwards. Okay? So some people, and it kind of depends on, you know, what makes the most sense to you. I saw some people that did this today, and it made more sense to them. They wrote it out like that. They put F into G, right? And then they just took negative 15 and put it in. So if it helps you to write it out like that, go for it. Okay, I'm just trying to show you different things. Some are like, I can just do the math. Okay, some like to see kind of where it comes from, why it comes from that, and how we get there. So whatever makes the most sense to you. On this one here, we're putting G into F, so we're going to put this whole function into the F function. So your answer, once again, is going to be an expression. Same thing for number 18. Your answer will be an expression. Okay, any questions so far? Okay, I'm going to let you guys work.